I'm going to do just a little bonus video here, and I went through several of these in another video, but I spent a lot of time on it. I'm going to talk about this one. A submarine starts at a depth of negative 15 meters and then dives down a 5/10 of a meter for every second. So he starts, that's 0. He hasn't done anything yet. He's going half a meter every second. 1 second later, he's going to be a half a meter further down. Okay. Right here, that's half a meter for every second. You can actually count how many half meters are there between here and here. And you would see that there's 4 half meters. So this would have to be 5 seconds, right? But that's reasoning. We can do it through reasoning, but we can also do it by creating an equation. And the way we can write the equation is, we know that we're changing at 5 meters a second. So when y, the depth, is at negative 15, we can go ahead and add that descent of negative 5/10 of a meter. By the way, we can, instead of saying adding a negative, we can just subtract. I'll rewrite that in a second. The value of x, well, they told me already that it was 0. Okay? Now this right here, I'm going to rewrite, but I'm going to use one of the other ones. I'm going to go ahead and use this 17, this negative 17 plus, I did it again, plus 5/10 of a meter. But this time it's 5, so x minus 5, okay? That's one form of how we can write an equation. And then, of course, I have to simplify. And I'm going to go ahead and say 0.5x, and then negative times the negative is going to be a positive. So this is plus 2.5, right? Yeah. These can combine, and I end up getting negative 15 is equal to negative 15 minus 5/10 is equal to y, like that. So there's my simplified version. Or you can write it, which is in the future you'll be writing it this way: negative the descent, the unit rate, negative 5/10 of a meter descending. That's why it's negative. I'm going down. And I'm already starting at the 1500s. That's my equation. Or you can use that one, for example. But you can use any of these equations to solve for the problems. Okay, so the 10 here, I'm going to use this equation. So y is equal to negative 0 and 5/10. And I'm going to say, instead of x, I'm going to go ahead and say 10. And then I get negative 5/10 times 10 is 5 minus 15. And I end up getting negative 20. Now let's see if that makes sense. I went an additional 5 seconds at 5/10 a meter descent in that 5 seconds. That would be 2.5 meters further from negative 17 and 5/10. And of course that is negative 20. Now this is a linear situation, so when I graph this, it should be a straight line. 0 is at negative 15. So if you can see, this is going by 2's, and 15 is right here at 0. And that 1 is going to be right here. 1 is going to be just barely below that. And then 5 is right here, and it's going to be all the way down to 17.5. Just right about there. And 10, which is right here, it's going to be all the way down to negative 20. So 14, 16, 18, 20. It's like right here. It's barely on there. All right, let's see if this forms a straight line. And it should if I did it right. And it looks like I might be off on one of those numbers a little bit. And that's probably just a hair off. And honestly, this is just a straight error. All right, well, there's my graph. The graph, well, that looks kind of funny, but that is what we have here. And how deep will it be after 25 seconds? Now, notice your graph is not very helpful for answering that question. My graph only goes to 10 seconds. X time is 10. So how deep will the submarine be after 25 seconds? Well, I can use my equation. Y is equal to negative 0.5 x minus 15. And then, so what is it going to be after 25 seconds descending? Well, I substitute in that 25 here. And I am going to... so this is like saying half of 25. Well, that's like negative 12.5 minus 15, which is negative 27.5. Okay, so I'm going to have descended 27.5 meters. Okay, how deep? So when you write the answer to this, you can write it as an integer like this, or you can say it descended. Oh, you're not even seeing all of that. Try to stop doing that. 27.5 meters. Okay, if I wanted to express it as an integer or a rational number, it would be negative 27.5, or you can use the words. When you're writing an explanation, you should use the words like descended 27.5 meters. Okay. How many seconds will the submarine be at a depth of negative 30? So once again, we write the equation, and we can go ahead and substitute in. And there's other ways. You can work your way down to that. It is pretty time consuming, but you can do it. But I'm substituting in the value of y now because I know how far it went. What I don't know is how long it took. So I'm going to go ahead and solve for this, and I end up getting negative 15 is equal to negative 0.5 x. You can either divide or times both sides by 2, so negative 2. Because negative half times negative 2 is 1. And so that's why I'm multiplying both sides by that. And I end up getting 30 seconds is how long it would take. 30 seconds. Well, that's only 5 seconds more, and we know that if it's going down a half meter, right here it went, so it's 2.5 meters every 5 seconds. So that actually makes sense. 30 seconds is just 2.5 meters further from what it was before. So that kind of reasoning kind of works. Let's do another one. A helicopter starts at a height of 50 meters. It rises 12.5 meters for every second. So it's rising. It's already at 50 meters, so at 0. And then it rises 12.5 meters for every second. Well, this is 2 seconds, right? 25 is double that, so this is 2 seconds. In other words, it's 12.5 meters for every second, so it's 25 meters for every 2 seconds. 2 more seconds later, it'll be at 125, or 125. And then 6 seconds altogether, that is going to be, so for every 2 seconds, it's 25. So that's going to be 25, 50, 75. It's going to be at 150, right? But we don't have to take our word for it. We can see that it's starting, and we're increasing. For every 1 we go up, we're increasing by 12.5. So 12.5 x, this is my equation. I have a constant of proportionality here. No, I don't. No constant of proportionality. We're starting with 50. Constant proportionality is if this were the origin, and it's not. So this is my equation. Of course, I could have created an equation using the same method I've been using, which is honestly, I realize for some of you, and if you were to ask help from your parents, they probably would kind of look at it and then look at you and say, huh? because this is something that we're going to talk about this form later. It does have a name. We're not going to focus so much on that. This is going to be 0. And then you rewrite this and you get 50 minus 12.5x minus 0. And notice that's that. But I could have used any one of these. I could have done it with 75. And I could have done it with x minus 2. In which case you would have ended up with 12.5x minus 25. These combine and you end up getting 50 minus 12.5x. It doesn't matter. You're going to always end up getting the same thing. So you could use any pair that you have in your equation to come up with this format, that form of an equation. Okay, after how many seconds will the helicopter be at 100? Well, we still haven't gotten to 9. It's 12.5 seconds, meters for every second. So a second later, we can extend out our reasoning, or we can use our equation. So y is equal to 50 minus, oh, it's plus. All of these are pluses. My apologies. Plus, because it's rising, not descending. Anyway, 12.5 seconds. And we're going to substitute in 9 right here. Okay? So 8 times that is 100. 112. Wow. Okay. So we can do we can do the long multiplication right here. I don't have a calculator on me, if you can believe that. So I'm needing to do this in my head. So, and I'm really tired, so I'm having a hard time kind of arranging all that. So it is what I thought. 112.5 plus 50, which is 162.5. So this is 162.5. Now I could have gone up 12 and a half for every second. So 12 and a half would be 162.5. Another second would be 170. And then that doesn't make sense. Okay, I made a mistake here. So let's see. 9 times 5 is 45. 9 times 2 is 22. 9 times is 11. And then I add 50, and 9 is 3 seconds. 12, this number must be wrong. Let's check that one out. We're going y is equal to 12.5x plus 50. And so 12.5 times 6 plus 50. Okay, so times 2 would be 25 times 3 is 75, right? Oh, this is 125. Yep, this is what I get for... So let's just double check that. Let's see, let's just double check that. 12.5 times 6, 0, 3, 2, 5, 1, and 750, which is 75. Yep, 125. So I messed up right here. That's why that wasn't making a lot of sense. All right, now we got it right. So 125, then 162.5. We can graph all of these, so 0 and 50. So it's going by 20, so that would be right here. 2 and 75, that would be right about there. 6 all the way up to 6 and 125, which would be right about there. And 9, which is right here, and 162.5 right here. Let's check this out with a straight line. And sure enough, those numbers line up. I feel pretty good about it. The next one asks, how many seconds will it be at 100 meters? So this is 100 meters, and it looks like it's 4. And but we don't have to take our word for it. We're gonna use the equation. Y equals 50 plus 12.5x. And we're gonna use times we're going to say 100 meters. That's how far it's up. 50 plus 12.5x. Subtract 50 from both sides. And I end up getting 50 is equal to 12.5x. And divide both sides by 12.5. Okay? Which is the same as saying 100 divided by 25, which is 4. So it is 4 seconds. And at what height will the helicopter be? 15 seconds. So we're going to use that same thing, 50 plus 12.5x. And we're going to go ahead and substitute in 15 right here. And again, I'm doing this longhand. 60125. And I have 187. So that's 187.5 plus 50, which is 237.5 meters after 15 seconds. Okay? But we did that by getting the equation first. The graph, the table, they aren't as helpful as having the equation, and that's the whole point. So, I mean, I can do more of these, but this is another fairly long video, so I'm just going to go ahead and stop there. Maybe I could do more practice here. There's more to do, but let's call it for there, and let me know if you're having troubles.